Welcome back to Communicating Your Results. Science is best communicated at multiple points throughout the process. Scientists record their findings in detail in lab notebooks and databases as they begin the research. They will present their findings regularly to their teams in lab meetings and in seminars. When the research has generated sufficient results, the researcher may go on to present their work at conferences or in symposia. Once the study has been completed, the work is further presented to the community in the form of posters and talks. The work is then written up, usually in the form of an academic paper, and submitted for review to a journal. If the work is considered to be exciting, it might warrant a press release, and it might be picked up by the news media and reported by the news outlets. Increasingly, social media is playing an important role in the communication of scientific results and findings, such as on Twitter and Instagram. As the audience grows, the specificity and nature of the language and presentation used will change. Feedback and peer review. So scientific work is reviewed in the following way. When an author submits a paper to a journal, it generally follows this process. The editor will conduct a preliminary investigation or assessment of the work, and if it passes, they will send it on to review by reviewers that are experts in the field. This means that they will have themselves written several articles or peer-reviewed manuscripts in the area of the submission. The review process can be blinded. Either the reviewers are blinded to the identity of the author, or both the reviewers and authors' identities are concealed during the process. Or it can be open, when all the identities are openly available to the public. For some publications, the review process is actually interactive, and what this means is that the reviewers and the authors can engage with one another during the review process. Once completed, the editor will assess the reviews, and if the reviews were positive, the editor will either accept it and it will go on to be published, or it can be rejected, or the editor can recommend that revisions need to be done to the manuscript, and then it would enter the review process one more time. Ethical behavior in science. Good scientific behavior is characterized in several ways. It's important to pay attention to what other people have done, because science is a cumulative process. This means that scientists study their fields extensively to understand the current state of knowledge. They will review the existing peer-reviewed literature. They will attend conferences and webinars by other scientists. Scientists will try to stay current in the field or with progress in the field. If you found something to be true, you must allow other people to test it. This is critical to the progress of science, which aims to understand the natural world. You must also assimilate all the evidence. You can't ignore any evidence. When scientists are faced with evidence that might contradict their ideas, a scientist can do more testing. They may revise or reject their original idea, or they may come up with alternative ways to explain the evidence that they've generated. If ideas are not supported and sustained by evidence, they will be rejected by the community. Scientists must also frequently and openly communicate their ideas and tests to others. The sharing and communication of science is really, really important. If a scientist keeps what they have learned to themselves, others cannot build upon those ideas, double-check the work, and devise new ways to test the ideas. It stops and blocks the process. But scientists must also have integrity. Hiding evidence, selectively reporting evidence, faking data, directly thwarts the main goal of science, and that is to construct accurate knowledge and understanding about the natural world. Institutions have mechanisms in place to ensure integrity. My institution, the New School, has an office devoted to research, and it provides resources and training in responsible conduct of research and in protecting human subjects. In addition, institutions will have an institutional review board that will conduct reviews of proposed research in advance of the research being conducted to ensure the protection of human subjects. In the case of animal subjects, an IACUC committee will perform the same function. What comes from science? Well, the first two things that we must think about is the differences between theories and laws, which are the ultimate goals of any scientific progress, right? We're trying to come up with theories and laws. Theories are based upon several repeated observations and investigations. If new information is gathered that doesn't support the theory, it will be modified or rejected. Theories aim to explain the why of something happening. They're usually more complex than laws and can contain multiple hypotheses. Laws, on the other hand, are built upon observations of similar events that have been witnessed repeatedly. If new observations do not follow the law will be rejected. Laws state that something will happen. Theories explain why things happen. A law is based upon one well-supported theory or hypothesis that states something will happen. So that's the difference between the two. And here are some examples of theories and laws. Theories such as germ theory or atomic theory have been developed through years of observation and experimentation and the accumulation and synthesis of knowledge from many different contributors. But they remain theories because they could in fact change. Should new evidence or data emerge or new interpretations of existing data. Laws, on the other hand, such as the ideal gas law at the bottom there, dictate what will happen. They, generally speaking, are not subject to change. A law will predict reproducibly something will happen. Let's pause here for assignment 3.